Smart manufacturing didn't start with fancy robots. It began with a problem. A factory that just couldn't keep up. Picture this, an industrial district in Lagos. A company making precision shafts and housings for farm equipment. Inventory was a mess of spreadsheets. So when a critical part failed, the whole production line stopped. When a batch of parts was made incorrectly, no one knew for hours. Scrap rates were high, delivery times were long, and profits were shrinking. The managing engineer, Tunde, saw the real issue. It wasn't the machines themselves. The problem was information, or rather, a lack of it. He proposed a bold move, a full transition to smart manufacturing, guided by the principles of Industry 4.0. This wasn't just about buzzwords. It was a complete redesign of their entire system. Phase 1 was all about connecting the physical world to the digital one. Temperature sensors were placed near critical bearings. Power meters were installed on each machine. Suddenly, these silent machines started talking, streaming a constant flow of data to a central dashboard, using the industrial Internet of Things. Overall effectiveness, and instantly see why a machine went down. Within weeks, clear patterns emerged. One particular lathe consistently showed more vibration during heavy cuts. Predictive analytics flagged that its bearing was starting to fail, long before it could break and shut down the line. For the first time, maintenance became proactive, based on real conditions. Unplanned downtime dropped by an incredible 28%. Phase 2 went even deeper. This was a perfect virtual copy. Now, when a new order came in with tough specifications, they ran simulations in the virtual world first. The digital twin predicted exactly how the machine would behave. This blend of physical machines and digital models slashed setup. Next came Phase 3, data-driven quality control. Traditionally, parts were inspected after they were made. Feeding that data directly into control software, it would automatically adjust the machine's settings to correct it. They were no longer just catching defects, they were preventing them from ever happening. The scrap rate fell to less than 2%. Finally, Phase 4 tackled logistics. Automated guided vehicles, or AGVs, began moving materials around the factory. When raw material levels got low, the system automatically ordered more. The factory was no longer a collection of separate departments. It was a single, integrated, intelligent network. Throughout this journey, Tunde, the engineer, had a revelation. Smart manufacturing didn't make his job obsolete, it made it bigger. The modern mechanical engineer now needs to be a systems thinker. The results after 1 year were stunning. A 35% reduction in downtime, a 22% increase in output, and an 18% drop in operating costs. But the biggest change wasn't in the numbers. The factory had transformed from a collection of dumb machines into a thinking ecosystem. And in this new world, mechanical engineering had become the art of designing systems that think. Thanks for watching. If you found this journey into the future of manufacturing interesting, don't forget to like, subscribe, and hit the bell for more.